Hello and welcome everyone. I'm Ravi and today we'll be going through another complex example of how to use permutations to do counting problems. So in this example, we're given that Harry has 5 books, but the only complexity that is there is that two of the books are duplicates of each other. So let's imagine that the books are B11 and B12. They are duplicates of each other, but then there are 3 more books that are distinct from these two duplicates, which we will mark as B2, B3, and B4. So the question that we have asked is the same as before. In how many ways can Harry select 3 out of these 5 books and place them on a table? So to divide this problem, let's first imagine that there are 3 buckets on the table. So bucket 1, bucket 2, and bucket 3. And to solve this problem, we'll imagine there are 2 specific cases in which Harry can distribute these books. So one of the cases is when he considers both the books together, and the other case is when he considers and picks only one of the books from the distribution, or he picks none of the books from the distribution. So let's start with the case where he picks one or none of the books from the distribution. So in that case, the set of books that he can pick from is 4, which is B11 or B12, B2, B3, and B4. And there would be four distinct books that have to be placed in 3 different buckets. So for this, we go back to our previous example wherein if you had n elements and you want to place these n elements in k different buckets, the way to do this is, and the number of ways to do this is n factorial by n minus k factorial, which turns out to be 4 factorial by 4 minus 3 factorial. That turns out to be 1. Sorry, 4 factorial. It's 24. Or 4 factorial by 1 factorial. Now let's come to the interesting case wherein he picks both the books and is allowed to only pick one from the rest. So there are 3 books, 2 of them are distinct, and he has to place them in 3 buckets. So one way to solve this problem, and we can solve it in multiple ways, is imagine that there are 3 buckets. And now Harry gets to choose one of the 3 books. So we'll first consider in how many ways can he actually choose the combination of the books. So he can choose one of the 3 distinct books in 3 ways. He can either choose B2, B3, or B4. So we'll say that the number of ways of choosing comes out to be 3. But for every choice, let's say the choice that he made was B11, B12, and B3, how many ways can he actually put these books in these 3 different buckets? So a simple way to think about this problem is imagine and try to answer the question in how many ways can he put that one distinct book on the 3 buckets. There are 3 ways. B3, let's say the distinct book is B3, can either go in bucket B1, or it can go in bucket B2, or it can go in bucket B3. So that turns out to be 3. And the rest is just putting B11 and B12 in either of those buckets, but that really doesn't change the distribution. And so we end up, because these 2 books are not unique, and so we end up with 3 ways of putting a particular selection of books on the table, and we also end up with saying that there are 3 ways of selecting each such choice. And so we end up in a multiplicative way of 9 total ways. And why is that so? The reason is that we have a task, and this task can be created in 3 ways, But for each task, there is subtask of distribution which can be done in three ways. So we end up multiplying them. So the total number of ways would actually turn out to be 24 plus 9, which is 33. Hope this gave you an idea of how to solve counting problems when you need to figure out distributions, but there are duplicates. The generalized form of this problem would be slightly more complicated, and we'll not touch upon that. But this is a good way to learn as to how do you decompose a problem and then apply simple techniques of figuring out the number of permutations and then building up from that. Thank you, and I hope this video helped you clear your concepts even better.